Mining and metallurgy are very much complementary areas of engineering, in the sense that mining focuses on extraction of the raw materials and the basic processing. Metallurgy then will refine core materials out of the raw materials and will produce useful products. And that's where it becomes very interesting in metallurgy, because of course metallurgists are allowing us to do a lot more with a lot less material. In terms of the mining industry, it faces many challenges because on one hand ores are becoming less concentrated and energy costs and labour costs and so on in Australia are quite high. Also, the mining industry in Australia is moving from investment in new mines towards operation of those mines. This means they'll be needing to cut their costs because globally they will have to compete.
Energy is a big concern in the industry, and the two biggest areas where it's used are in moving ore out of the mine and to wherever it's going. And the other big one is grinding the ore down to a size where you can separate valuable metals out and discard the waste. So we know that if we keep doing things the way we've been doing it in the past, that our energy costs are going to triple or quadruple, because the grades of the ores that we're treating are so much lower. So we have to treat so much more rock, which is worthless, to get that pound of copper or that ton of iron ore out. The other really big challenge is that people are more aware of energy costs. So there's pressure from communities and there's pressure from governments to try and reduce the energy demand of the mining industry. The mining industry has been identified as a major energy consumer and also an industry where there's potential for energy savings.
Hi, it's Francis Barham here. I'm a Director of Innovation and Strategy at Ensight. I'm here in Pilbara Mining Company in South Africa. We're doing an environmental management project to reduce energy use and costs at this mine. Energy efficiency is actually not important to our clients. They don't give a crap about it. What they care about is saving money. What I need to do is show the client how they can save money by taking on the concept of energy efficiency and apply it to their business. When I first went to that site in January 2012, I had to basically establish, is there any justification to be engaged in that site to look at energy efficiency? And to do that, I had to convince the Managing Director and the senior management team it was worthy of their time to pursue energy efficiency. His concern was that electricity prices had gone up 300% over the previous 4 years, and where before they were paying 20 million US for electricity, now they're paying 60 million US for electricity. Massive hit on their bottom line, and it was out of control, and they wanted to have something in place to manage that high cost of energy. The first thing we did was do what was called an energy balance, where we looked at all the flows of energy in and the flows of energy out, and we applied that to cost. So we did a cost of energy in, cost of energy out. And what it showed was that if we could save 20% of their energy use, they could save around 30% of their energy costs by targeting the higher energy intensive processes. It's a four-step process. They have an underground mine, a concentrator, a smelter and a refinery. And surprisingly, underground mining is quite energy intensive because there's massive air conditioning systems and massive ventilation systems. What became clear was that that wasn't managed to optimise energy. That was managed to optimise compliance with the code, and so we saw opportunity straight away for savings there. So our first major opportunity we saw was managing the system so it was responsive to demand. The next significant energy use is the concentrator. What we found in that system was that there was massive amounts of energy being wasted in processes that were batched, when in the non-batching times the same amount of water was being pumped, the same amount of crushers were being turned, and so what we looked at there was matching the systems better to the need and reducing the amount of water wastage. And the last process, the refining, The opportunity there was both in the management of the electrolytic process and the high temperature electrolyte, which is around 72 degrees Celsius, how that's heated again through using coal. So we looked at better management processes and optimization of the heating processes.
The mining industry in Australia is one of the largest consumers of energy in Australia. It consumes around 11% of all energy produced in Australia. A large amount of that energy is divided both between the processes of mining and mineral processing. In the mining area, a major consumer of energy is the transport of material through to the mill. The majority of that material at the moment happens to be waste. Typically we have to transport much more waste than we do ore or coal through to the mill or the water plant at this stage. So if we can devise initiatives that involve transporting less material or transporting material over reduced distance, that's a major energy saving. Looking into the future, the mineral processing aspect, which is simply the crushing and grinding of rock, is the number one consumer of energy, and there's a lot of work looking at how to develop more efficient processes for the crushing and grinding of rock.